Welcome to lecture 4, part 2. So we will be doing a lot more examples on rational expressions and a few examples of domains which have non-rational expressions as well. So remember the domain. So when it's a rational expression, the domain is everything but the numbers which make the denominator to be 0. So you don't even have to look at the numerator. If you want to find what's not in the domain, just factor the denominator. So keep the numerator like that. Now there are situations where you have to factor the numerator. Finding domain is not one of them. When you find the domain, just factor the denominator. Okay, so the denominator here, the factors of -2 is -2 and +1. So this is how you break it apart, and then you do x squared. Let's say take common factors, x times x minus 2 plus 1 times x minus 2, which means you get x squared minus 3x plus 2 divided by x minus 2 x plus 1. So the only impossible values to put in is x minus 2 cannot be 0 or x plus 1 cannot be 0, which means x cannot be 2 or x cannot be -1. X cannot be 2 and x cannot be -1. Now how would you write it in interval notation? Because all the questions in the exam, when we ask the domain, we will ask you to write it in interval notation. Now if you feel confused about this, what you would do is just draw a number line, okay, and then locate these numbers. So let me just, as we did in class, let's put -infinity here and infinity here, and the numbers are 2 and -1, so -1 here and 2 here. So we will not have -1 and we will not have 2. So anything here is okay, anything here is okay, and anything here is okay. So now you can see it's -infinity to -1, and then -1 to 2, and then 2 to infinity, everything with parentheses. So -infinity to -1, -1 to 2, and then 2 to infinity. Okay, that's how you write it in interval notation. Okay, now because it's similar, let's look at example number 4. Okay, again same, don't worry about the numerator, doesn't matter what the numerator is. You would factor the denominator. Now 2 times 3 is 6, so we are looking at factors of 6 which will add up to -5. That would be -3 and -2. We need to have the same sign because this is +6. So we have -3 and -2, that would add up to -5. So 2x squared minus 2x. So I'm going to split it as -3x and -2x. So 2x squared minus 2x minus 3x plus 3, which is equal to, factor this, 2x x minus 1 minus 3 times x minus 1. So now we can see the common factor here, take it out, x minus 1 times 2x minus 3, x plus 1 is on the top. Now here x cannot be, this one cannot be 0 and this one cannot be 0. So x minus 1 is not equal to 0, that means x is not equal to 1. 2x minus 3 cannot be 0, that would be x is not equal to 3 over 2. Not equal. Again, if you need to be really sure about what your interval notation is going to be, draw a number line from negative infinity to plus infinity and put these numbers. 3 over 2 is 1, 1.5 and 1. So any number from here to here is valid, any number from here to here is valid, and these numbers are valid. So you can see that is negative infinity to 1, and then 1 to 3 by 2, and then 3 by 2 to infinity, and that's it. Okay, now you can go and do the question you can see on the right hand side of the screen. Okay, now let's look at the examples 2 and 3, because these examples are different, because these are not rational expressions, these are square roots. Now when you have a square root, the inside, so if you have a square root expression, take the inside and make the inside greater than or equal to 0. So what you have here is 4x plus 1, that's the inside, make it greater than or equal to 0. You see there are no square roots here, it's just 4x plus 1 greater than or equal to 0. Subtract 1 from both sides, so you get 4x is greater than or equal to negative 1, and then divide by 4, so you get x is greater than or equal to negative 1/4. X is greater than or equal to negative 1/4. How do you do it on the number line? Negative 1/4 is here. X is greater than or equal, so it's all these numbers. So in interval notation, that would be negative 1/4 to infinity. Okay. So that's how we do it. Take the inside and set it greater than or equal to 0. Okay. And 3 minus x, again take the inside and set it greater than or equal to 0. 3 minus x greater than or equal to 0. 0. Okay. I would add x to both sides. So you get 3 greater than or equal to x. Or in other words, x is less than or equal to 3. Can you see that these two are the same? If not, just look at it for a moment. You can see the arrow points towards x. So it's the same thing. Okay, so in interval notation, draw the number line and x is less than or equal to 3. So it can be 3, it can be anything less than 3, but no more than 3. So that would be negative infinity to 3. Alright, now you can look at the left side of your screen and answer the question regarding the domain. Okay, now let's do the divisions. Okay, now when you do the divisions, you need to remember that you have to factor things and then cross things off. There's no point of multiplying everything and looking for common factors. It's never going to work. So let's try to factor things. Now, right now I'm going to assume that you know how to factor things. So for example, let's do a quick factorization on a side. X squared minus 3x minus 4. Factor of negative 4, that would add up to negative 3. That would be negative 4 plus 1. So split to negative 4x plus 1x. So x squared minus 4x plus x minus 4. So factor this x times x minus 4 plus 1 times x minus 4. Factor that x minus 4 times x plus 1. Okay, it's not a final answer, but I just circled it. And x squared plus 5x plus 6. Factors of 6 that add up to 5, that would be 2 and 3. So split the middle to 2x and 3x. So x squared plus 3x plus 2x plus 6. Now you have x times x plus 3 plus 2 times x plus 3. X plus 3 is common, x plus 3 times x plus 2. Okay. And lastly, factor x to the power 4 minus 16. Now we learned factoring in the previous lesson, so you can see that this is a difference of two squares, and that would be x squared minus 4 times x squared plus 4. Because this is the difference of two squares, x squared squared minus 4 squared, and use the formula a minus b times a plus b. And again, this can be factored as x minus 2, x plus 2, and then x squared plus 4. And that would be the complete factorization of that. And last but not least, well, I think that's okay. Also, I would write 4 minus x as negative of x minus 4. Okay, that is something I need to do. It's just like I would like to see how things cancel off. Okay, so let's rewrite all the terms and then just do the division. So 4 minus x would be negative x minus 4. This can be factored as x minus 2, x plus 2, x squared plus 4, divided by x minus 4, x plus 1, over x plus 3, x plus 2. Now because we are doing a division, you just flip the second term, so this goes here and this comes there, and it becomes a multiplication, and then you can cancel things off. X minus 4, x minus 2, x plus 2, x squared plus 4, x plus 2 on the top, x plus 3 on the top, x minus 4 on the bottom, x plus 1 in the bottom. And see how things cancel off. That cancels off, that cancels off, and that's it. So carefully write what's remaining, and that should be your final answer. Negative x plus 3 divided by x minus 2, x squared plus 4, x plus 1. That's it. Okay, so let's do a quick summation and a subtraction here. So remember, what you need to do is find the least common denominator. And you can see that this is x minus 1 times x plus 1, right? So you have x minus 1 times x plus 1, x plus 1 times x plus 1, x plus 1. So x plus 1 and x minus 1 are the factors, and you take the highest exponent. Now the highest exponent of x plus 1 you see 1, 2 and 1, so that's 2. Highest exponent of x minus 1 you see 1, nothing, nothing, so that's 1. So that is the least common denominator. Okay, so now let's write down the term, write down all the terms and try to make the least common denominator in all those terms. So x plus 1 goes here. So just write down what was originally there. X plus 1 squared, and then 3 over x minus 1, x plus 1. And let's try to make this guy in all three of them. Now the first one is missing an x plus 1, and that would make the x plus 1 squared work, and then also missing an x minus 1. So when you write it in the bottom, you need to write it on the top. Okay, and here x minus 1 is missing, and x minus 1. Here you have 1 of x minus 1 which is there, and then 1 of x plus 1, but you have to have 2, so x plus 1 and x plus 1 here. So once in blue was originally there, and once in red we introduced it because we need to have the same denominator, and now you can see we have the same denominator. So once you have the same denominator, you don't write it 3 times, you just write it once, x plus 1 squared times x minus 1, and write down the numerators, x plus 1, x minus 1, minus 2 times x minus 1, plus 3 times x minus 1, x plus 1. So all you need to do now is to just simplify the numerator. FOIL this, or you can use the special formulas, minus 2x plus 1 plus 2. Minus 2x, minus 2 times minus 1 is plus 2, plus 3x plus 3. And that ends up being x squared plus x plus 4 over x plus 1 squared, x minus 1. Now at this point, stop and see whether the top has factors, because if you have factors you have to factor it. But luckily in this situation you can see there are no more factors. None of the factors of 4 will add up to 1. That's it. No more factors, and that's the final answer. Now look to the left hand side of your screen to see the next question. Finish that question and we'll move on to the next page. Okay, so let's simplify the complex fraction. Use the method 2. So we did this method 2 in class. So what we do is find the least common denominator and then multiply the top and the bottom with the least common denominator. Okay, and the only denominators it has is just square root of x squared plus 1. There are no other denominators, so that would be the only denominator, which is the least common denominator in this case. So you are going to multiply the top by x squared plus 1 square root, bottom by square root of x squared plus 1, the same thing. But because there are more terms, more than one terms on the top, you will distribute. Remember, this was this very common error that I see all the time, people not trying to distribute it. So make sure you distribute it and write it on all the 3 terms. So let me write down what was originally there. X squared plus 1, x squared minus square root of x squared plus 1 divided by x squared, and square root of x squared plus 1, square root of x squared plus 1, square root of x squared plus 1. That's it. So now you can see how things cancel off. This goes off and you get x squared, and square root times square root of the same thing, so it's just the term without the square root, divided by x squared square root of x squared plus 1. Now here you have x squared minus x squared plus minus 1, and then that goes off. You get negative 1 over x squared square root of x squared plus 1. Okay, so you see that it has all the things we learned in this lecture. So one of those questions I like. So I would say exam question alert. Okay then, so let's do the next one because we need more examples. Okay, and I'm gonna write this slightly differently, just factoring the top so that I can see what the least common denominator is. Okay, now all I did was factor the second term on the top, and you can see the denominators we have x plus 3, x plus 3, x minus 3, x plus 3, and x minus 3. So the common ones are just x plus 3 and x minus 3. So least common denominator is x plus 3, x minus 3. So now we will multiply both the top and the bottom by x plus 3, x minus 3, x plus 3, x minus 3. So it goes in all the 4 terms. So remember, do the distribution step. So again, not the way I do it, but just for the sake of clarity. Okay, so in red, let's write down what's the LCD. And when you write down the LCD, you can see how things cancel off nicely. Like that. Like that. Oh. Oh. Okay. Not like that. Like that. So. Okay, so the x plus 3 term is, x minus 3 term is still there. I'm so sorry about that. I'm not going to do this video again, so let's keep it like that. That goes off and that goes off. So all you end up with is on here x times x minus 3 minus x plus 6 divided by x times x minus 3 plus 4 times x plus 3. So that's what you remain, and you can see there's no more complex fraction. It's a nice good fraction. So just simplify it. X squared minus 3x minus x plus 6 minus 6, and x squared minus 3x plus 4x plus 12. So finish it by x squared minus 4x minus 6 and x squared plus x plus 12, and that is your final answer. As you can see, there are no more factors. Okay, so let's because I said exam question alert, it might help you to do one more question about that. So on your left hand side of the screen, you will see it momentarily. Good luck. Alrighty, so this lecture looks like it's long, but again, I need to explain all these examples to you so that you've seen these things before. Alright, let me write this again in a different form. 3 to the negative 1, x to the negative 2/3, x plus 1 to the power 1/2, plus 2 to the negative 1, x to the 1/3, x plus 1 to the power negative 1/2. Now, the key factor here is pick the least exponent of each of the terms. So write all the terms. 3, I have 2, I have x, and I have x plus 1. And pick the least exponent that is there. So the least exponent of 3 you see is -1. The least exponent of 2 you see is -1. The least exponent of x you see is -2/3. And the least exponent of x plus 1 is -1/2. So also I'm going to do this placeholder thing, and that would be 2 to the power 0 here and 3 to the power 0 here. Why did I do that? Because I would like to see what powers of 2 and 3 I have, and I don't have 2 and 3 in both terms. Now I do because of the placeholders. Now remember the way we did it in class. You take out this term, and then in order to find what's remaining inside, you would subtract the exponent from the already existing exponent. So we might need a little more space here. So let's take out the least exponent term. So 3 to the -1, 2 to the -1, x to the -2/3, and x plus 1 to the -1/2. And see what we have here. So from the first term, okay, so 3, we had -1, we are subtracting -1. Okay. 2, there's this term 0, 2 to the power 0, so we had 0, we are subtracting -1. X, we had -2/3, we are subtracting -2/3. And x plus 1, we had 1/2, we are subtracting -1/2. So now this looks like a really big simplification, so have a good look. Don't write things down without understanding it. Okay, now let's go to the second term. 2 to the powers, we had -1, we are subtracting -1. 3 to the power, we had 0, we are subtracting -1. X to the power, we had 1/3, subtract -2/3. And x plus 1, we had -1/2, subtract -1/2. I'm going to write this here. X plus 1 to the -1/2 minus of -1/2. Okay, see, most of the things will become 0. So if it becomes 0, it just becomes 1. So you can just cross it off. This becomes 0. So cross it off. This becomes 0. So this cross it off. And this becomes 0. The exponent becomes 0. So cross it off. All this becomes 1. So what we have inside is actually 2 to the power minus -1, that's 2 to the 1. X plus 1 to the power 1/2 minus -1/2, that's plus 1/2. So that's x plus 1 to the power 1/2 plus 1/2. That's that. And here we have 0 minus -1, that's 3 to the 1. And x to the power 1/3 minus -1 2/3, that's 1. So 3 to the -1, 2 to the -1, x to the -2/3, x plus 1 to the -1/2. Now you can just send it to the bottom. So finish this problem by writing 2x plus 2 plus 3 over 2 times 3 times x 2/3, x plus 1 to the 1/2. So finally you should get here 3x. So 5x plus 2 on the top, 6 x 2/3, x plus 1 to the power 1/2. Okay, again, these are questions that again uses a lot of concepts. So these can be used in quizzes, exams, or you might see these in web assigned questions, and also one of those homework questions. So be alert. Okay, now let's do the last example on that section. There's one more in the next page, but a different example. So let's do this one right here. Again, remember we are taking out the least exponent and also add the placeholders. So you can see there are no x terms in the first term. So let's add the placeholder x to the power 0. That will be really helpful in this calculation. And now the least exponent out of these two would be x to the power -2, and the least exponent out of these two would be to the power -1/2. So x squared plus 3 to the power -1/2. Okay. Okay. So let's take it out. Oh, well, let me do it in a different way. Let me do it in a different way, and if you find this easier, do it this way. So what I'm going to do is make these exponents positive. X squared plus 3 to the power plus 1/2. So make the exponents positive. Okay, and then multiply the numerator and the denominator by this guy. So let me write this down again. X to the 0, x squared plus 3 to the power 1/2 minus x to the -2, x squared plus 3 to the -1/2. And this is what you already have. Okay, and multiply the numerator and the denominator by this quantity right here, x squared plus 3 to the power plus 1/2, and x squared plus 3 to the 1/2. So I made the negative exponent positive and multiplied the top and the bottom. The reason is once you multiply it, once you distribute it, you will see the negative fractions gone. Okay, so just write it again. All over. This is power to the 1. So the same thing to the power 1, same thing to the power 1/2. So you can add them. So that would be x squared plus 3 to the power 3/2 times x squared. Okay, and then here I'm going to distribute. So x squared plus 3 to the power 1/2. Here x squared plus 3 to the power 1/2. Now what's really important here is that you know all the rules of exponents and you should be able to apply them. Okay, right now what happens here is x to the power -2, x to the power 2, that becomes 1. X squared plus 3 to the power -1/2 and x squared plus 3 to the power plus 1/2, that becomes 1. So this thing becomes a huge 1. And then plus 1/2 plus 1/2, that's 1. So, and then 0 plus 2 is 2. So you have x squared plus 3 minus 1 over x squared plus 3 to the power 3/2. And then you can actually simplify this a little more. X to the power 4 plus 3x squared minus 1 all over x squared plus 3 to the power 3/2. And that's it, because there's no more factors on the top. none of the factors of 1 adds up to plus 3. So that's how we do it. So I exhibited two methods to do these type of questions. You can do either one of them to do the next question that appears on the left hand side of the screen. All right, so the last example in lecture 4 is these type of questions. Now it's a very interesting question because you don't know what to do. Okay, so I give you a quantity and then ask you for something quite different, right? That's what you see there. So what would you do? So in these type of situations, the only thing that can be done is, well, look at this. You have square root of x squared plus x plus 1, and here you have x plus 1. So probably squaring might help. That's the only idea. So you don't know anything, you don't know what to do, but it looks like squaring might help. So let's square both sides. Square this and square this. Why? Because that's the only thing I can do. That might help. I mean, you can just do random stuff that doesn't help, but this is like the only thing that you can do that might looks like it helps. So let's file it. Remember, never do the freshman's dream. File it. And these two, just x plus 1, these two plus 1 over x plus 1, and then minus this times this would be just, let me write this down, and then minus and you can see that these two cancels off. So what you have here is x plus 1 minus 1 minus 1 plus 1 over x plus 1 is equal to 25. Okay, these three you can simplify. X minus 2 plus 1 over x plus 1 is equal to 25. Add 2 to both sides and see what happens. X plus 1 over x plus 1 is equal to 27. And that, my friends, is what we exactly looked for. X plus 1 over x plus 1 is equal to 27. Okay, now you will see one of the homework problems that looks exactly like this. So that's the reason behind including this question. Okay, and let's do the last example here. Simplify the difference quotient. Now I believe I did this. If I didn't, this is the way to do it. What you do is rationalize the numerator. So remember, you multiply by the conjugate. So conjugate for 2 plus h minus 2 root 2. The conjugate is square root of 2 plus h plus root 2. So you multiply the top and the bottom by that. So square root of 2 plus h minus root 2 over h. You multiply by the conjugate. Square root of 2 plus h plus root 2. And then yes, if you can of course file it. So let's file it. That would be 2 plus h, and then this would be negative root 2 plus h, and this would be plus root 2 plus h, and then the last one would be minus 2. That last step was just filing. And you can see these terms cancel off. So you get 2 plus h minus 2 over h, times 2 plus h plus root 2. Now again, you can see more things cancel. And even more things cancel. Now this is the point where you can see that there are no more h's in the bottom. You have 1 over square root of 2 plus h plus 2, and that should be your final answer. So whenever we ask you simplify a difference quotient, this guy is called the bad h, and you need to simplify the question until that bad h gets cancelled off, and that was right here. So once you do that, you get the final answer, which is this. Okay, again, this will also use some things that we talked about. So again, you can see these questions frequently. These are very frequent questions that all the TAs and I like. So finish this lecture by answering the question on the left hand side of the screen, and thank you very much.